Day 10. Day 10. So far, not too bad. For the first 9 days were not too bad. I hope the last, the last few are okay. Mainly today and tomorrow. I'm not gonna be able to do the 12th day live anyway. So just these. Okay. Maybe a graph problem. Dijkstra's would be nice. I don't know. I don't know what else there is. That's about it. Although it's been a while since I did Dijkstra's, but it would be fine. This interesting. Okay, just cross all you find a large factory. Tells you how a manual. We have this. The manual describes one machine per line. Each line contains a single indicator light diagram in square brackets. One or more button wiring diagrams in parentheses. Okay. And voltage requirement in curly braces. Okay. To start the machine, its indicator light must match that shown in the diagram, where dot is off, hash is on. The machine has a number of indicator lights shown, but its indicators are all initially off. Okay, so some of them have to be turned on. 4 indicator lights, which are off, and the goal is to simultaneously configure the first light to be off, the second light to be on, the third light to be on, and the fourth light to be off. Wait. They're all off. Oh yeah, you want to do off, on, off. Okay. You can toggle the state indicator by pushing any of the listed buttons. Each button is listed. One or more button wirings. 0 is the first light. So here, each time you press the button, the first, fourth, and fifth indicator lights would all toggle. Okay. You can push each button as many times as you like, however, at the same time, fewest total presses required to correctly configure all indicator lights. You could press this one with the 4.8, total 5. It's 2. Okay, so this is just DP. We could just do dynamic program with all the states. So the fewest, what is the fewest presses for each one? Okay, that seems okay. This is a pain in the neck to parse. Okay. Uh, let's see. I guess I want to take. I need to find this. Okay. Let's take off the first thing. And then let's split it on this. So then you get target and the rest of the line. And then rest. Oh, you know what? I actually want without the last character. And so rest dot split space open bracket. And then that gives you buttons. And we can voltage, which we're going to ignore for now. So then off, on, off. So we should just convert these to zeros and ones, right? So the target is uh is a tuple of C equal to this. C in target, right? Okay. That should be zeros and ones. And then buttons are one equals zero. And then buttons are. Hi, Catherine. Thanks. We have the parentheses. I don't really care about the parentheses. I guess we just split on the lines. Or on the spaces. And then but it doesn't really matter. The buttons are gonna be commas, and then we're gonna map int. And we'll make this a tuple also. Ooh, input parsing. Okay. Yeah, trombone game. Solve target buttons. Okay. And then print part Y. Okay. Solve target buttons. Oops. So we just keep track of how many states we have at each point. So steps equals 0. States. All the states we can achieve. I mean, there's all the states we've already achieved. But we don't actually have to keep track of that. We just need to, well, I guess if we've already achieved it, we should just throw it away. If we see something again, if we cycle into something, do we need to keep it? I guess it doesn't matter. Does it matter? No, it could. No, no, no. Because we do have to keep track of button presses. Right. We just keep track of all the new states. So we should only get n squared states each time. Okay, anyway, states equal set, and the original state is 0 times right. We just start with one state, which is everything is off. And then while it's true in this case, new states, and then state for state in states, and then for button in button. buttons. For each button, we take the state. I guess this is fine. How big are these? None of them are that big, right? Well, I could have the buttons rather than being a tuple. Make it a set. It's a tuple. I plus the index. Okay, let me do len. Or in range n. It's going to be state I plus I in button. Sorry, I'm sick. Mod 2. Close tuple, close add. Sorry. And then we set it, and then we go again. Okay. Let's see. In object's not scriptable in button. Oh, right. Wait. Button's not append. Buttons. So the first one is false. True. Okay, that looks right. 2, 9, 3, 5, 6, 7, 9. Okay. That's correct. int object is not subscriptable. State. States. State is a set. This maybe didn't work correctly. Let's try that. There we go. Okay, straightforward. Everything was parsed. Okay, time to worry about the voltage. Switch the button from giving the indicator light to increasing the voltage. I'm gonna get water. Okay. The machines each have a set of numeric counters tracking the voltage level. One counter per voltage requirement. The counters are all initially set to 0. Means that the machine has 4 counters which are initially 0, and the goal is to simultaneously configure the first counter to be 3, the second to be 5, 4, and 7. Each button indicates which counter it affects. The second and fourth counters each increase by 1. Okay. Counters are all 0. You can press these buttons. So I think we ignore the first part. Configure the first machine's counter requires a minimum of 10 button presses. What we do is pressing the 3 once. Three once. 1 3 3 times. 2 3 3 times. 0 2 once, and 0 1 twice. So is it the same thing except I'm subtracting from these? Because there's no looping around, so it must be you only do it once. So I think we start at these, and then each time you press, you subtract the value. And then you're trying to get to all zeros. If you ever go under 0, then you just throw it away. Does that mean you're going? Yes. I'm pretty sure that's all that is for this. How long does this take around? Not super long, but let's see. So voltage is, we don't have to run it at the same time. Please finish quickly. You need backup. Okay. This, if I'm understanding the problem correctly, this shouldn't take long. So we have voltage. We split off that part. We already took off the end character. So voltage. We can do buttons there. That's part 1. And then we can do, let's do the voltage string here. We're gonna split. Whoa, whoa, whoa. And then we're gonna map int. And I think we just make it a list. No, we can do a tuple. think tuple is better. Yeah, I think tuple is better because we don't really want to modify it anyway. Uh, voltages. Okay. Part 2. Solve J. It doesn't matter. Voltages. Oops. Solve J. Buttons. Voltages. So we have the initial state. This is very similar. Set the tuple, which is the values, and then step is 0. This is the same. Okay, while true. New states for okay, so for each button, we're gonna make a new tuple. So it's gonna be a tuple. It's gonna be for I in range n again, and it's gonna be oh, we're still doing core states. State I minus let's see, I in buttons. This is okay. This is a new state, and if new state, if the minimum value in here is greater than or equal to 0, well, if it's less than 0, then we ignore it. It's bad. New states dot new state. And then here, if well, I guess we can exit, right? We've targeted new states. If some new state equal to 0, if they're all 0, then we turn steps. Otherwise, we append it and we keep going. And then here we do states equals new states, I think. Port 2 is not defined. New states. Append, no, add. Oh no, some of these have big numbers. These are not big numbers. But I guess if there are enough buttons, these are big numbers. Let's do some print buttons. So we'll do it here. Even the first one's taking too long? Really? Must be doing something wrong. These numbers don't look that big that they should take that long. I guess the branch factor is very, very high. Is the branch step factor really, really high? I guess so. We could have started at 0 and gone up. Would that have been faster? There's probably some way to do it with like GCDs. Yeah, I should be doing this with GCDs. Wait, is that true? Or is there like a constraint solver I can do? I guess the other way to think about it is like here I can calculate how many times can I press this. How many times can I press this? How many times can I press this? And then multiply it out. Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 buttons. Well, 81 to the 10th would definitely be too many, right? So maybe I have to do something smarter here. Yeah, I think I have to do something smarter here. Hold on. This is not that easy. I think the number of states grows too fast. So instead we have to be smarter. If there's only a couple buttons, it's easy. But when you have lots of buttons, it's hard. Like this is easy. But when you have 10 buttons, I mean, we could do a system of equations, right? It's like this is n1 times, this is n2 times, this is n3, and we could just loop on each one. But we want the minimum one, the minimum button presses. I guess if you want the minimum button presses, you always want to do the one with the most numbers first. No, not necessarily, because it might put you into a state that you can't get out of. No, because all the other buttons can always increment by one, right? No, it could put you in a state that you can't get out of, right? But in general, you want to do the one with the most times. Why is this so complicated? Because there are lots of combinations. One, eight. Hmm. I'm missing something. And there's always a solution. It just seems like there's so many combinations. Like in my DP tree, it's the product of these is the number of states I could be in, right? Uh, that's a lot of combinations. I mean, technically, we can't be in all those states, but we can be in a lot of those states. I feel like there's some sort of something with matrices for solving this. One, two, three, four, five, six, seven. One, two, three, four, five, six, seven, eight. Yeah, I mean, so you want to do this as much as possible. And you want to do this as little as possible. Yeah, this is just way too big. That is such a big number. How else can you do this? Okay, let's break it into each component, each digit, each button. Let's take 0. 0 can be this one or this one, or this one or this one. There are 4 things that impact 0. So they all have to add up to 57, 59. Oh, is this just systems of equations? Oh, this is just a multivariable system of equation, right? With the added caveat that you have to find the minimum. Okay, let's try a similar one. Let's try this one. So the 0th button, we have A equals 0th button, A, B, C, D. 0, 1, 2, 3. So this is going to be, oh, let's call it B1, B2, 3, 4, 5, 6. So B1 times some number of presses. Oh, wait. No, we're talking about B5 times, wait, A times, okay, we're going to press it this many times. P5 plus P6 equals 3. That's for the 0th. P2 plus P6 equals 5. That's for 0, that's for 1. For 2, we know P3 plus P4 plus P5 equals 4. And then we know P1 plus P2 plus P4 equals 7. But in this case, we have 6 unknowns, 4 equations. But we can't just loop on the different values, right? Wait, you need the minimum number of button presses. So you need at least 7 button presses here. But here the most P4 could be is 4, which makes these both 0. Yeah, does this work? Okay, suppose I say P4 equals 4, which means P3 equals 0, which means P6 equals 3, and then P2 equals 2, and then P1 equals 1. 4, 5, 6, 7, 8, 9, 10. Well, that does work. What if that didn't work, though? What about the cases where it doesn't work? I maximized whatever the maximum in here was. I took the thing that needed the most, and I looked to see what had any constraints. But it was pretty arbitrary, right? Oh wait, why did I pick P4 as a constraint? Why didn't I pick P2? What if P2 was 5? That would also have worked, right? P6 was 0. P5 would be 3. Yeah, I mean, this does work out in this case, where I just start maxing and I start solving. This is some sort of linear algebra thing. What is it, though? I feel like I did something like this in linear algebra class, but I don't know what it is. I forget what this is called. You like max something and then you see if it works. I mean, what if I started here and I maxed like P5? It's less efficient. I feel like you always have to be maxing one of these and working from there because that's always the most efficient. And if it doesn't work, then you max it by less. Yeah, I mean, I picked this, but what if I had started here? Doesn't matter which one you max with first. I mean, these are the two I care about, right? Because it increments the most numbers at once. Hi, Dank. I feel like there's a name for this. That was in part 1. It doesn't mean anything in this one. It doesn't mean anything in the second part of the problem. It was in the first part of the problem, but the first part of the problem was much simpler. Okay, let's look at this problem. It's much harder. So many buttons, oh my god. Uh, I'll format it differently. And this is the target. So, well, we'll do it in order. So the ones with zeros, it's P1, 2, 3, 4, 6, 7. Oops. 7, 8, 10. So here we know that P5 plus P9 plus P10 equals P9, and then everything with a 1 in it. Oh wait, I even missed one. P3. Everything with a 1 in it, which is P7 plus P8 plus P10. So what does this tell me? So twos, everything with a 2, P1 plus P5 plus P6 plus P P7 plus P9 plus P10 equals 81. But even if this does do this, yeah, there's gotta be something with matrices here. Right? Is there a way for me to make a matrix? And then add the matrix? Not add. Multiply it? No, it's gotta be powers. It's gotta be powers of matrices, right? And that applies all of them until we get to this? No. I mean, okay, this could be a matrix, right? This could be a matrix of ones and zeros. Times a matrix for these values. And then it equals a matrix for these values. Right? So then can I do matrix division? Can you divide a matrix? Matrix times a vector equals a vector. God. So matrix times a vector equals a vector. So then is it a matrix divided by a matrix? Can you divide a matrix? Matrix times vector equals no, vector. As a linear transformation to the vector resulting in a new vector where the no, it's fine. Well, then can you right? So this seems to be okay. And then what's oh, you do an inverse? How to reverse matrix vector multiplication? Right. How can I calculate vector if I know matrix and result? So when I multiply matrix and vector, yeah, that's what I want to know. A matrix MILP? What's MILP? But now it's the inverse of the matrix times B. But some cases it's not invertible. I forget what it means to do an inverse of a matrix. Okay, it sounds like I make a matrix and I invert it and multiply times B. It's probably LU decomposition. Computing explicitly the inverse of a matrix is usually a bad idea. How do you invert a matrix? The verse is Gaussian elimination. This sounds right. It's n cubed, that's fine. I don't care about that. specify linear algebra solve. Overdetermined or undetermined. For instance, where the matrix is not square. More equations or fewer. Oh, it doesn't work. Okay. That sounds like this as well, right? Because we could be under or overspecified. Is that the case? Is that ever the case? 1, 2, 3, 4. 1, 2, 3. Yeah, see here we only have 3 buttons. We have 3 equations. Yeah, here we have 3 equations. Uh, well, technically we have 3 equations and 3 unknowns, is that right? No. No, because our equations go the other way. We have 4 equations. You always have this number of equations. No, it's always a square, right? You always have a number of equations equal to however many values we're computing. Yes. I think this is correct. But is there always, what if there are multiple answers? Okay, let's just try it. Import numpy as NB. A equals. Okay, let's do it with a sample. Sample problem. Yes. Oh yeah, see this is an example where I had, it's overspecified. No, I have 4 equations. That's okay, right? Integer programming. What, is this not gonna work? Uh, my first equation is 0, 0, 3, 4, 5, 6. 0, 1, oops, 0, 1, 0, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. B equals 3, 5, 4, 7. And I'll solve. The last 2 dimensions of the array must be a square. Yeah, does A have to be a square? The coefficient matrix must be a square. Oh yeah. Oops. Yeah. I think I have to do some sort of brute force. I think I have to do like LU decomposition because it's not a square. Because it could be over or under specified. And I need like a specific answer. Oh, this is way too hard for me. All right. The other option is I can use Z3, probably. Examples. Integer constraint solver, right? Okay. From Z3, import star. So if I were doing this problem again, let me write this in Z3. Well, let's see. P1 equals int P1, 2, 3, 4, 5, 6. Yeah, that's weird that it output it that way. Anyway, and then what I know is oh, oops, P5 plus P6 equals 3 equal P2 plus P6 equals 5, P3 plus P4 plus P5 equals 4, P1 plus P2 plus P4 equals 7, and also P1 is greater than equal to 0, P2 is greater than equal to 0, P3 is greater than equal to 0, P4 is greater than equal to 0, 5 is greater than equal to 0, P6 is greater than equal to 0. Is there a stream delay? Maybe. Uh, you know, my computer just starts dropping frames randomly. Let's see. 2, 3, 4, 5, 6. This gave me an 11 solution with 11 button presses, which I think is not optimal. 4, 5, 6, 7, 8, 9, 10. This is not optimal. It gave me a solution, but not a good solution. Uh, 3C solver, find min. Uh, minimizing value. S dot minimize x. S equals optimize. Okay, so let's try this. And then this equals optimize. And then add all our constraints. Uh, add all of our constraints. And then let's add presses. Presses equals int. Oops. Presses equals p1, p2, p3, p4, p5, p6. And then we want to minimize presses. If else. No solution. I guess I could copy that. Okay, that's what I'm gonna do. I need to do this from here on. Yep, paste it. Let's go. X is not defined. What is X? What is X? Oh yeah, that's not X, that's presses. Do we have M? Presses is 10. Yeah, that works. Should we just do that? Should we just use Z3? Z3 feels a lot like cheating. I kinda wanna go to sleep though. What time is it? It is 10:10. Okay. I wanna go to sleep. So we're gonna do it this way. It's pretty cheaty. Z3. Okay. How do I do this? How do I do this in code? Oh wait. How do I do this in code? Um, what do I have a variable for number of buttons? That's okay. Okay, so we label the buttons. So then we do the buttons equals. You don't have to matrix up at all. Really, it feels like a constraint solver problem. It feels like very linear algebra. I tried to just do it recursively, dynamic programming, but there's just too many combinations. I don't know how to go faster, I guess. Int b plus for I in. Yeah. So we have a button. And then s dot add. How do I write this out? For whichever one it's in. There's gotta be a way to write add. C solver. That's not what I want to do. That's how you add constraints. It's because they're overloading operators. I mean, I guess I could have it generate code. I would write force by taking the longest set, using the most of them possible, and reduce the problem to have one fewer set. Use the most possible, and then recurse on the other ones. I thought about that. If it doesn't work, do n minus one, because this will find you the minimum, right? And then you take the next longest and the next longest, and so forth. It's like 10 minutes? Really? Holy cow. That's a ton. Wow. I know I've dropped a lot of frames, but I'm surprised it's that far behind. I wonder where that. It must be because of my ISP, right? Or is it my computer? Is my computer too slow? You know what? Maybe my computer is not able to compress fast enough. Is that possible? I don't know. That seems possible. It's definitely easier for me to write the code for what you're suggesting. But also, what do you do if there are two that are equally long? See, okay, like here's the problem. The problem is something like this. How do you know which one to take the max of? I guess you see which one you can take the max of. Or maybe it doesn't matter. I guess in that case it doesn't matter. You maximize this one as much as you can. And then this one. And then you subtract one. And then you do this one, this one, this one, this one. And you just recurse. And because you're starting at the max, It should go the fastest. And then do you have to cache? Do you have to cache the values then? I think what you're suggesting actually makes sense and is probably correct. It would just suck if I tried it and it didn't work. I would feel bad, right? Because alternately, I could just write code that generates that writes the Z3 code and then run the Z3 code on each input. How many of these are there? 195. I wonder if I could even run eval on it. Probably. Um, but yeah, you're probably right. That's probably the right way to do it. We just got to start the other direction. That's recursion with backtracking, basically. You're talking about doing recursion with backtracking. It doesn't matter if they're multiple with the same number of buttons because right. All right. I'm gonna do Z3 method because I know it's gonna work versus the backtracking method, which may or may not work. It probably would work, but if it doesn't work out, I'm gonna feel bad that I wrote all that code and then it didn't work. And this should at least get me to bed, I think. Okay. So, oops. Which I'm not sure how eval. And then can I just run it through eval? I think so. I guess we try it for one of them and then we see. And then we can do what do we want to write? I guess I was using P, so we'll use P. Yeah. P. Oh, we called that. Do I put an F in front of it? I can do an F in front of it. And then whichever ones have a 0 in it, we add it to equal this. Although we change this to 0. Oops. 4. This is what we want to end up with. So I guess we just want to collect the values. For I in n if for t in range is t in buttons I, we would do the, and then we want to join the sucker, and then wait, why is it not like this? Plus equals t. No, old is t. Think equal. And then we actually want this to be why don't you like that? Oh, VS Code, you're getting confused. Wait, because I'm missing that. So just T. Close prep. Okay. Uh, greater than 0, greater than equal to. Okay, and then join. These are all the presses. equals this thing. Ah, it's late. That's why the light went out. Process equals. Oh, that's why I had this. Right. Close paren slash n. Okay. And then we gotta do the solve part, which I think is down here. Right. That's do I want to print it? No, I just want to set it equal to something. Answer equals. I'm not printing. Equals presses. You're good. I'm just inspiring you. I think you're probably right. I think you're probably right that that's the right way to do it. Recursion with backtracking. M equals s dot model. Okay. Let's just try one of them. See if this is right. Oops. Yeah, I think this is too complicated. Presses. Join. Plus. Close paren. Oh yeah, because I tried to write it out. Well, that doesn't look right. That looks right. I think. Wait, I feel like I missed an optimized line. Better at this. Okay. Now eval. What does eval even return? I don't even know. Not anymore. We can't do any imports. And why is that invalid syntax? What can I do rather than doing eval? It has to be an expression. Exec. Hmm. Presses is not defined. Right. I didn't define presses. Presses equals int. I don't know. I don't know if this is working. Oops. Hi, Catherine. I'm sorry. This is a hard problem. Okay, so I think that worked. This didn't return anything, but what if I just do this? Will return, if I exec it, uh, is it in my namespace all of a sudden? That was not defined. What is exec return? Python exec return. What returns none? And in scope once the code runs. Code to execute. I see. My locals. Wait, it's not available for the outer scope. Can I do that? Yes. And I can do something like answer equals none. But when I call this, I call globals. So it'll have my answer. There. I still got none. Crit. Let's see if that works. Yeah. That's what Hank was saying. It's a 10-minute delay. Yeah, the light went off at 10:30. 112. How do I get that back out though? There we go. Uh, Everything's correct. Return. Return. Why did it write 0 plus? What else am I printing here? Oh, here. I don't know why there's an extra print there. Plus. What is this output? I don't want to print this. I don't understand what happened here. That all looks correct. But then why didn't it not add correctly? What is the type of this thing? Not work. Whoops. Oh, it doesn't like this. No, here it doesn't like an int. Which is say z3 convert z3 equal to int. As long. Why? Oh, I know why there's a 0. Alright.